Alright class, this is your introduction to dependent sample t-test, or also called paired sample t-test. So in this video, I'm just showing you the introduction, the theory behind it. There are some assumptions we have to create, or we have to check before we use it. But for, just for the sake of this video, we'll just kind of make sure we're going to level set so that we understand exactly what it is we're looking at. So we should be familiar with this idea. This is our population, okay, and we have a sample that comes from that population. Right? There's your sample. And previously what we had done was taken a statistic, usually sample mean or proportion, whichever one you want to use, and had some hypothesis test about the value of the population parameter. Okay? So we assume, for instance, that mu is equal to some value k. Okay? But we'd assume that the proportion is equal to some value k prime. Okay? And so then we'd calculate our z-score. And our z-score, assuming that we could use the z statistic, would be z is x minus mu over sigma over root n for our mean. If we couldn't, we'd use the t statistic, which is x minus mu over s over root n. And for proportion, we still would be able to use the z, but it would be p hat minus pi over root pi 1 minus pi over n. So these were our statistics that we compared to our critical values with the one sample t-test. Okay? So now we have data on groups of information, or not necessarily groups, but related groups. So for instance, I have this. Okay, so let's say I have a group. Okay, so here's a sample. Samples x, and I take values x1 to xn, and I take their measurements at time t. Okay, so maybe it's the number of jumping jacks they can do in a minute. Okay, and then there's some intervention that happens. Okay, in other words, some time lapse. Let's just call this a time lapse. Okay, and I look at their values later. Same group of people. Okay, x1 and xn. And what I want to know is, and let's say this intervention, for example, was a 4-week exercise program. So as a baseline, I found out how many jumping jacks they can do in 2 minutes, and then I gave them this 4-week exercise program and looked at their amount of jumping jacks they can do in 2 minutes at 4 weeks later. Okay, so this is a classic type of analysis where you could use the paired sample t-test. And you know it's paired because each person here, okay, is the same person here. So I don't have two different pieces of information. I have one person that I'm just taking two measurements on. Okay, same with x2, same with x3, all the way up to xn. So if you think about how many independent pieces of information, I really don't have two independent pieces of information because it's the same person just done twice. So I have n pairs of pieces of information. So if the degrees of freedom dealing with independent pieces of information, I have the degrees of freedom is going to be based on n minus 1 pairs of information. Okay? So before and after is a common one for when you would be able to use this test. Another one is pre-test, post-test. Right? Pre-test, post-test. All right? Okay? So those are common. When you see something like this, you'll say, okay, I need to use paired sample t-test. And you'll normally get the idea because you need to have the same number of pairs, same number of values in each group. But there's not just a pairing in time, there's also a pairing in space. So if you consider one group of family members, and in this case I'm looking at husbands, okay, and then here I'm looking at their wives, and I'm collecting data in each case, right? Is there a difference between husbands and wives, for instance? You really don't have N types of data. Now, let's say we're looking at spending patterns or spending habits and see how spending habits has decreased or increased over whatever time period you're interested in. Well, you got to imagine that since husbands and wives live in the same household, their spending habits are going to be similar to each other. Okay, they have to be similar to each other. And since they're similar to each other, they don't give us independent piece of information. So I really have one household here, two households there, three households there, four households there. Okay? So in terms of independent piece of information, I would have four or N pairs. So if you have family members, when you're looking at results of studies from family members, or before and after, or father-sons, or anything like that, you're really looking at a paired sample test instead of an independent test. Okay? So there's the setup for you. Now let's see, how do we use this to create our analysis. So when you look at it, we have data at time t, and we have data at time t prime. And the question is, are there any different? So since we're looking at paired t-tests, we need to actually consider the difference in each person before we average it. Okay? So for the paired sample, the thing of interest is the difference. Sorry about that. The thing of interest is actually the mean of the difference. Okay. What do I mean by that? Let's say I had three people, and at first it was 10, 4, and 7. And then in a time step later, I remeasured them, and it was 13, 8, 9. Okay? This is at time step t. This is at t plus 1. Okay? If I wanted to find out if this has increased, okay, I have to first find out the difference, 13 minus 10, and this is 3. 8 minus 4, and this is 4. 9 minus 7, and this is 2. Okay? These are called your differences. Okay? And in statistics, we have a nice symbol for difference. It's actually the lowercase d. Okay? So this is your differences. So once I have the differences, I take the mean of the differences, which is just the mean of the differences, which is 3 plus 4 plus 2 divided by 3, which surprisingly is nice and neat, 3. Okay? So this is what we want to interested in for the mean of the differences. Okay? We first take the difference, then we take the average. Now what's interesting is when we look at the independent sample t-test, we take the average of the difference. Okay? So don't get it mixed up. Mean of the difference is paired sample, difference of the means is the independent sample. So, okay, so that's nice and all, but how do we set up our question? Okay. And all right, let's go to the next page. Difference is based on this sample mean, the mean difference of the samples. Okay, so our null hypothesis is that there is no difference. Okay? And our alternate hypothesis is any of the two that we had already, is that there is a difference, or the difference is less, which means that, it got worse, or the difference is greater. which means it got better. Now, there are times when you would want to have a negative difference. Okay? So, for instance, can you think of an example where you want to find a before and after that's less than when you started? Okay? What about that same program, the 4-week exercise program, but rather than look at number of jumping jacks, which I would want this to increase, okay? I would want this to increase if I was doing an exercise program. Over time, you should be able to do more jumping jacks. But what if I looked at weight loss or weight? Okay, when you first started this program, you're at a certain weight, and then over 4 weeks, you'd expect that that weight would shrink or get lower or get smaller. And so those are examples where you'd want to have a mean difference that's less than what you started. Okay? Another one could be debt. Let's say you started a financial program and you started with $12,000 of credit card debt, and over the 6-month period, you were able to knock it down to $4,000. That would be a success. So just because the means are less than zero, on average, the average mean is less than zero, does not mean it's a bad thing. Okay? And so here's the cool part about it. Okay? Now, since I have this D bar, you really just break it back down into a T statistic. Only difference is, rather than use our interest statistic of a X bar, we're actually going to end up using D bar. Because what we calculate is the sample mean difference. That's what we're calculating based on our sample. And what we assume is that the mean difference is zero. Okay? So now since I put that on there, you should see something that's an error here. Okay? In each of these cases, our D bar can be equal to zero, not equal to zero, less than zero, or greater than zero. But that's not our null hypothesis. Remember, our null hypothesis and our other hypothesis are based on the parameter value, not our sample value. So since we have to consider our parameter value, the actual null is that the mean difference of the population is zero. We still make the assumption that the sample we took was taken from a population. Okay? We don't need to do any estimation of the sample mean difference because it is what it is. If you calculate 7, then the difference in mean, the average mean difference is 7 of that sample. What we want to know is that large enough for the entire population. So mu D is less than 0, greater than 0, or also one-sided examples. So again, you take what you've calculated, which is D bar, subtract off mean, divided by the standard deviation, which in this case is the standard deviation of your sample means. Of your difference. SD. Okay. So in our previous example, we had a difference of 2, 4, and 3. You'd find the standard deviation of that data, and that's what you'd plug in here. Okay. And that's it. And then you'd have a T statistic with n minus 1 pairs of degrees of freedom. So if we had 3 minus 1, 2, you have 2 independent pieces of information. Okay, now, when we look at this, we should see something different. Okay? We know that we're looking at the mean of the differences, but I only have the standard deviation of that data set of means, right? Which means that I need to take, since I took the average difference, I still have to do a sigma over root n type of thing. So I still have to take my standard deviation of my difference and divide it by the square root of n. Okay? Uh-oh. Okay. So your t value is d bar minus mu d over st over root n. Now, you can calculate your standard deviation the same way you calculate the. You could actually use a formula. If you're doing it by hand, this is kind of computationally efficient, so I'll give it to you quickly. So if I took my samples, okay, and I had, 3, 4, 2. Let's just say I have 3, 4, 2. These were my differences. And I looked at the square of the differences. D squared would be 9, 16, and 4. And the sum of the differences would be 9 and 25 is 29. Okay. This is just an example to show you how it will work. First thing I do is take the size of my sample, which is n, and add up the d squareds. Okay. So in my example, I would plug in 29 for this term here, and I'd plug in 3 for the n. Okay. Then I have to subtract off the sum of the d's squared. Okay. So in that case, I would have plug in 9 squared and have 81 there, over n times n minus 1. So for our small example, I would do this. Equals, and this is if I'm doing it by hand, of course. The square root of n is 3 times d squared, sum of d squared is 29, which looks like about 87 to me. Yep. Minus 9 squared, which is 81. So we know the top 87 minus 81 gives us 6 over 3 times 2. Okay? So the square root of 6 over 6 equals 1. So our data has a standard deviation of 1, which makes sense since the mean is 3, and I have one value that's a point over it, and I have another value that's a point under it. So that's an easy way to calculate the standard deviation. You could have gotten the same thing by doing x minus mu squared over n minus 1, taking the square root of it. But just realize that this is a easier way to find the standard deviation by hand. Okay, that's all I have for this small module. Do realize, though, that we have paired data, but the question is, should we still use this paired sample t-test? And to determine when you use the paired sample t-test, there are 4 assumptions that we need to make. Okay? One of them is that the dependent variable is continuous, which basically means interval or ratio data. So I can't tell you the difference if the value isn't exactly different. Okay? So in this case, I want to make sure that my values are continuous. I'm looking for the difference in means. Okay? The second part is the categorical. And so if I'm breaking it up by pre-test and post-test or something like that, then I have one group that's pre-test, one group that's post-test. So that's what we mean by independent. Okay? They have to be related or matched groups. The third thing is that we have to have no outliers in our differences. And that becomes important because when you have outliers, you know it blows up that standard deviation, which means your t-test is likely not to be found significant. And then the fourth one is one that we don't really have to worry about as much because of the central limit theorem, but we want to have the differences in that dependent variable to be approximately normally distributed. Okay? So that's it for me. Wait for the next video when we'll actually see how we would do some paired sample t-tests. Take care.